Let's quickly get into the next problem, and I'm going to do a different method this time, where I'm going to ask you to solve along with me, right? So firstly, let's go to the next problem. I would like you to copy this down. I'll give you 30 seconds time. Just copy this table down. So this is a 7 by 7 matrix. The live students could write it down as we are speaking. The students who are watching it recorded could pause the video and write this table down. Alright. So let's look at the shortest distance between two taxas. It is very evident B and F are at 0, 1. So what is it that we need to find out? So let me make a note of it in the whiteboard. The gap between BF is 1. Alright. So what is that we need to find out? Let's go to the next slide. We need to figure out the distances between A and BF, C and BF, D and BF, E and BF, and G and BF. Let's figure out the distances. So A and BF is distance between AB and AF by 2. You have the table in front of you. I'd like you to calculate it yourself. You could use the slide as a reference frame. Let me just walk you through a couple of them. A and BF, which is nothing but AB and AF. AB is 19, AF is 18, so you have 18.5. Similarly, let's look at C and BF. C and B is 31, C and F is 32, hence it is 31.5. I would request you to calculate D and BF. Live students could calculate it on the paper. Recorder students could pause and do it. You could do E and BF. And finally G and BF. So now you make the new table. The table now becomes a 6 by 6. Whatever you see on the red are the new entries. Now let's try and spot what is the least in this. The least looks like A and D. Alright. So let's write this down. A and D is 8. Let's go to the next slide. Let's try and draw this tree here. We go over to the slide. We go to the whiteboard. You can see B and F as 1. So it's drawn as B and F as 0.5 and 0.5. And on the right hand side you can see 0 to 0.5 is B and F. So we could write B, F, perfect. Let's go to the next slide. Yes. We've already identified the gap between A and D as 8. We've done it. So we need to look at how do we find out the distance between the rest of the elements. So what are we going to find out? We need to find out between BF and AD, C and AD, E and AD, and G and AD. Alright. So let's look at distance between BF and AD. So distance between BF and A is 18.5. The distance between BF and D is 17.5. So the average is 18. The difference between C and AD, which is C and A and C and D, 27 plus 26 divided by 2 is 26.5. Similarly, distance between E and AD, E and A is 33, E and D is 31, so the average is 32. So distance between G and AD, the G and A is 13, G and D is 14, so the average is 13.5. So let's, from a 6 by 6 it's become a 5 by 5. You can see all the new entries in yellow: 18, 26.5, 32, 13.5. Let's see how to represent this in the form of a tree diagram. Let's go to the whiteboard. We have the value of AD is 8, so each side is a 4. So you have AD at 4, 4 and B at 0.5, 0.5. So on the right hand side at 0.5 is BF, at 4 is AD. Let's go to the next level of clustering. You can make out the least distances between BF and G. BF and G is 12.5. Now what is going to happen here? Are we going to do weights? Are we not going to do weights? Let's wait and watch. This weight is WIT. Let's go to the next one. So we need to fill all of this distance between AD and BFG, C and BFG, and E and BFG. And let's do a calculation of that. We will naturally do a weight because BF is 2 and G is 1. BF is 2, G is 1. Hence you need to do a weighted average. Let me move over to the whiteboard. I'll demonstrate to you there. Let's take a look at the whiteboard. We first merged B and F. B is 1, F is 1, so I don't need a weighted average. We then merged, clustered A and D. 1 and 1, I don't need to do weighted average. But at this time I'm clustering BF, which is 2, and G, which is 1. So hence I need to do weighted average. So let's come back to calculate distance. We're looking at the gap between AD and BFG. So we need to find out between AD and BF, which is 18, and AD and G, which is 13.5. I need to multiply it by 2 because AD is 2 elements, so you have a 16.5. Similarly, distance between C and BFG, the C and BF is 31.5. On the right hand side you can see I'm multiplying it by 2. Yeah, 31 point, yeah, that's the way, 2. And the distance between C and G is 29. So it's 63 by 29 by 3, it's 30.67. Similarly, E and BFG, I would request you to calculate it yourself, but remember to multiply it by 2. Correct. Into 2 plus 28. So you got the new averages of 16.5, 30.67 and 33, and this matrix has now become a 4 by 4. The new values are mentioned here. Let's look at the computation of the tree. We have BFG as 12.5. So you can see 12.5 divided by 2, 6.25. Hence the G purple is completely 6.25. Whereas the line that comes from BF, it's 5.75 because we already have a 0.5 in red. So the red and the purple is equal to the complete purple. So that's the funda here. So at 0.5 came BF, at 4 is AD, at 6.25 is BFG. Let's now go to the next level. Least is 16.5. We're looking at BFG and AD. So let's write it down. BFG and AD. BFG dash AD is equal to 16.5. Will we have weighted? Of course we will have weighted because we are mixing 3 and 2. So we need to find out the distance between C and AD BFG. Let me explain this to you. The distance between C and AD is 26.5, and because we are clustering with AD, it's 2. You can see on the right hand side it is 26.5 into 2. Now let's look at the gap between C and BFG, that is 30.67, and BFG is 3, so hence we multiply 36 into 3 over there, and the net average is 29. You can use a calculator if you want. Let's look at E and AD BFG. E and AD is 32, AD is 2, so it's 32 into 2. Plus we are looking at the gap between E and BFG. E and BFG is 33 and it's 3 elements, so 33 into 3, so the average is 32.6. Now let's look at, these are the new averages. Let's look at the tree now. BFG AD is 16.5. Now 16.5 is, this is how it looks like. 16.5 divided by 2 is 8.25. So that's the straight diagram you have over there. BF, AD, BFG, AD, BFG. All right. I think you're getting a good grasp of this. The least is 29, so we need to merge AD, BFG and C. AD, BFG needs to be clustered with C, and the distance is 29. And again there will be weight because AD, BFG is 4 elements. Now the 5, C is 1. So we'll have to do into 5 into 1. So we need to find out the gap between E and CAD. The gap between E and CAD BFG is nothing but the distance between E and C and E and AD BFG. The distance between E and C is 41. That's only 1, so you don't need to multiply it by any number. The distance between E and AD BFG is 32.6. We're looking at 5 elements here, so it's 32.5 into 5, so you get 34 as the average. So this is a 2 by 2 matrix we've restricted to is 34. Let's look at the, so we had a gap of 29. Let's see how the tree looks like. 29 by 2 is 14.5. So on the right you have the C line, which is 14.5, yes, and on the left you have a 6.25 because you already have a 4.25 and a 4. So 4 plus 4.25 plus 6.25 is equal to 14.5 on the right. So in a singular line you can see 0.5 is BF, AD, BFG, AD, BFG, AD, BFG, C. Now one thing that is left over is E. Let's go look at the table. Now E is 34. So 34 is divided by 2 is 17. We can do the diagram straight away here, and you see the black line. E is 17, and this is how the clustering is done. So we did this quite fast. If you would like to watch it again, go to the recorded class and watch it again. And let's quickly do another problem. I am in the mood to do one more problem for the day, and let's close with that. Problem 3, you have a 5 by 5 to begin with. Here we will do the diagram at the end of the problem. Let's go to the whiteboard and let's write down AB is 30. AB gap is 30 is the least. Let's go to the next. So we need to calculate the distance. Go back one slide. I would like you to calculate the distance, and I'll show you the answer. In this, I'm not going to walk you through the method. I will be displaying the answers to you. So we are looking at merging A and B cluster. So you need to find out the gap between C and AB, D and AB, E and AB. So how do you do it? So let's try and do it here. C and A is 60, C and B is 30. So C and AB is 60 plus 50 by 2, which is 55. Let's do DNAB. DNA is 110, DNB is 90, so it's 200, it's 100. Similarly, let's do ENAB. Yeah, 90 plus 80 is 170, divided by 2 is 75. 90 plus 80 is 170, divided by 2 is 85. So let's go over and see what the solutions are. You have 55, 100, 85. Let's look at the gap here. The least gap is E and D, 40. So let's write it down on the whiteboard. The DE gap is 40. Let's calculate the DE gap. So what's the gap between CDE? Let's go back one slide. I'll give you the data. CDE. So the gap between CDE is C and D, which is 50. C and E, which is 50 again. So C and D is 50. Let's look at AB and D. AB and D is 100. AB and E is 85. So 185 by 2, that's 92.5. Let's look at the next table and see whether we've got the answers right. I've drawn this simple one for you. There you see 92.5 and 50. And again, let's look at the least value that happens to be between D and C, which is 50. Let's write it down. Will the weighted average kick in? Absolutely, because you're merging D and C. I think the value is, no, C and D is 50. Yes. So there will be a weighted that will kick in. So we need to now find the gap between AB and CDE. So it's the gap between AB and C, which is 55, and AB and D, which is 92.5. So it's 92.5 into 2, which is 185, plus 55, which is 192. 40 divided by 3 is 80. So let's see how the table looks like. This is the table. 80. And again, the least distance is 80. Let's go and write on the board. The gap between AB and CD is 80. Is 80. Let's see how the diagrams look like. The tree diagram. There you see A and B. Let's go to the whiteboard. A and B is 30. So which means it's 15, 15. And D and E is 40. So it is 20, 20. You have C and D is 50. So that long green line is 25. That is 25. Yeah. This is 20. The short green line is 5. The short green 5 over here, 5 over here. The 80 is 40, 40 on either side. So that purple is 10 over there on top. That's a 10. And this one is a 15. So it's not to scale. So this is how the diagram looks like. Let's go to the next slide. So we did 3 problems for today. By design, I took you through in detail in problem 1. Problem 2, we did it together. Problem 3, you did all by yourself. If the live session was clear to you, well and good. If you want to go over it again, I recommend once the recorded classes are up, you could go over it again. So it's a fairly simple everyday problems of clustering that we did. If there are any doubts, please feel free to ask me. I'll wait for a minute or so. If there are no doubts, have a good weekend. No questions, Nandita?
No questions.
Thank you very much. Bye-bye. Have a good weekend.
Thank you. Bye.